All right, guys, we are ready for section 10.5 here and talking about other kinds of angles that we end up having inside of circles or around circles. And so let's start looking at this. So our first theorem here talks about tangents and intersecting chords, and they work just like inscribed angles. If you kind of look at these diagrams, they look like inscribed angles because the angle itself, the vertex of the angle, is right on the circle. And so it is calculated like an inscribed angle. So if we look at that first diagram on the left there, we have a tangent line on the outside, we have a chord coming through the center, they meet at the point of tangency and create angle 1. And some students have a hard time seeing exactly where this arc is cut, but right at that point of tangency, circling clockwise around to the other side of that chord, that's the arc that we're talking about that angle 1 creates. And so in this diagram it says that that arc is measures 210 degrees. And so that arc ends up, half of that arc ends up being the measure of the angle, because that's how we get inscribed angles as well. So if that's 210, angle 1 would have to be 105 degrees, just half of the arc that it cuts. So you basically ignore the rest of the circle over there. Same thing for measuring arc RST. So now we're going backwards. They're giving us the angle. They want to know the measure of the arc. And so the 98-degree angle there does cut arc RST. And so we would just double it. So 2 times 98 is 196. And so the arc measures 196. Okay. Okay, as we go on to the next slide, a couple other theorems on this slide. What if the angles end up being inside the circle? And so we're calling it the angles inside the circle theorem. Those angles measure half of the sum of the intercepted arcs. And so if we look at a diagram here of that, so we would have something like finding the measure of angle 1 in this diagram. And so it's the angle is just somewhere inside the circle. It's not a central angle. It's not at the center. The vertex is not on the circle, like at point A or something like that. The vertex of the angle is just somewhere inside the circle. And so the way we calculate those types of angles is we take the two arcs, so looking at angle 1, and maybe it's vertical angle if you want to think of it that way, and the two arcs that it cuts are arc DC and arc AB. And so when we look at those two arcs, we add them together and then divide by 2, and that's how we get the measure of angle 1. And so it still has that half concept in there, but it's just that we have two arcs that it's cutting instead of just one, like an intercepted arc. And so we would take the 30 and the 20 and add them together and divide by 2. So 30 plus 20 is 50 divided by 2. So measure of angle 1 would equal 25 degrees. And of course, angle 1 and angle 2 are supplementary because they form a line or a segment. And so measure of angle 2 would just be 155 degrees. We're not doing anything with arcs to find that one. We're just using the fact that they form a line together. Okay, so when the angle's inside, you take the two arcs, add them together, divide by 2. Okay. Another one, what if the angle is outside the circle then? So now we've hit them all. Now we've hit central angles. They measure the same as the arc that they cut. Inscribed angles are angles that measure half of the arc that they cut. If the angle is just somewhere inside the circle, you add the two arcs and divide by 2. And now we have the angle on the outside of the circle, and now you do the opposite. You subtract the two arcs that get cut and divide by 2. Okay? So you subtract the arcs, divide by 2, and so let's look at, there's actually 3 situations where this kind of thing can happen. So if you look at angle 1 down here in the bottom, we could have an arc on the outside of the circle, the red arc, and then the bigger arc, and then the blue arc on the inside there, closer to the angle, and so you would subtract those two measures and divide by 2 to find the measure of angle 1. Okay. What else could happen is you could have two tangents. And so if you have two tangents cutting, then that really cuts the circle in two different parts, not necessarily in half, but two parts. And so you would take the big arc, red one, subtract the blue arc, and then the smaller arc, and divide by 2, and that would give you the measure of angle 2. Okay, or you could have two secants. And so when two secants cut the circle, again, they cut a big arc and a small arc, and so you subtract those two arcs and then divide by 2. And that gives you the measure of angle 3. All right, so I don't have any specific examples within that, but we're going to, on the next slide here, we're going to look at some examples of those type. But you need to draw those 3 diagrams to see the types of angles that we can have on the outside of a circle. Okay, so let's look at this example. Basically the same thing. We have a secant and a tangent, so the angle is on the outside of the circle. So we have a big arc cut 178 degrees and a small arc cut 76 degrees. So since the angle is on the outside of the circle, we're going to subtract those two arcs. So 178 minus 76 divided by 2 would give you 51 degrees for angle x out there, or the measure of x, to calculate that. Okay, how about this one? Now the arc's on, the angle's on the inside of the circle, and they give us the 102 over there, but again, the 102 really doesn't have anything to do with the two arcs, y and 95. So we need to do the linear pair thing, or the supplementary angle thing. So if that angle is 102, then the angle just above it, or right next to it, that cuts arc AB, would have to be 78 degrees. Well, we're going to take that 78 degrees, and you can think of it two ways here. You can go y plus 95 now, divided by 2 equals that 78 degrees. Or you can think of it that you have to double the 78 degrees in order to equal y plus 95. All right? And so that angle ends up being 78 degrees. And so we would go y plus 95, or 95 plus y divided by 2 is equal to 78. So you'd multiply both sides by 2 and get 95 plus y equals 156, and then subtract the 95, and you would get 61 degrees for arc y. Okay, those could potentially be really the hardest kind, just because of the fraction that gets set up inside there. So make sure you understand that one. And then another one with the angle on the outside, cutting two arcs. Again, this is kind of the more complicated type, where they're asking you to find one of the arcs. And so again, you could look at it two different ways here. You could look at it as the big arc A minus 44, all divided by 2 equals 30. Or you double the angle, so that would be 60, double the 30-degree angle, that'd be 60. That's what the two arcs have to subtract to. And so if we just plug into the formula, A minus 44, all divided by 2, subtract the two arcs and cut it in half, is equal to the angle on the outside. Multiply both sides by 2 to get rid of that 2 in the bottom, and so you get A minus 44 equals 60. And then add 44 to both sides, you get 104 for that big arc out there on the outside. These are definitely problems that require practice. You just got to get used to whether the angle's on the inside, whether the angle is on the outside, or whether the angle is right on the circle, which makes it just half of the arc that's cut. Okay, so we'll do some more practice in class here. Okay.